Okay, so for today we have one job to do, and this is vector autoregressions. So this noon that I was talking with my colleagues during lunch, I mentioned them that practically I'm teaching cookbook here. So how to cook regressions and different econometric models. But at the end of the day, the jewelry of the crown is the vector autoregressive model. So today this will be in my focus. But before doing so, we should start with the general requirements. So before doing anything with the regression, that obviously we have to go through the following steps of preparing the variables. So first of all, we are using differentiated data in most of the cases. When we are not doing this, then it will be absolutely model specific. So vector error correction methods are not using differentiated data. ARDL is not using differentiated data. But mostly the rest of the models will be using them. So and also we need this because of stationarity. Input will be required.
Yes. The recorder button.
I did. I think everything will be.
Okay.
Yeah, it's running.
Okay.
Thank you for reminding me because So we need stationary input data. And people are saying that, oh, ADF test is outdated, we should use other ones, but if you are still checking journal papers, people are still publishing. Or sometimes they are not publishing anything, but usually one of the 2 or 3 reviewers will ask for the stationary test result. But doesn't matter if you are differentiating the data until we are working term spreads on the yield curve, then it will do the job, so we will have stationary data as well. Next thing, logarithm. So it's highly necessary to have data on similar scale. This one is much more about the beauty of the data set, because at the end of the day, regressions will work just fine, but the coefficients will look really stupid that we have a scale of 1 million and the rest of the variables will be on something really small. So Isaac had this many years ago when we were thinking that maybe logarithm would be much better, or reviewers were asking for it. Obviously, we cannot use logarithm on negative values, so if we have any interest rate data, then logarithm is not nice. Also, sometimes people don't like when some of the variables are logarithm and some of them are not. At the end of the day, from mathematical point of view, it doesn't matter, but for some people it can be relevant. But in the past, I was mixing them in many cases. So if you are working with GDP, it's always necessary to use logarithm, because otherwise you will just have huge numbers and huge changes. Or if the data has this exponential growth tendency, then it's also much more elegant to use logarithm to remove this. Logarithmization will never remove outliers, so there is this illusion sometimes in the literature, but we should forget, or at least we should downscale the data, so by dividing it with removing zeros. Or z-scoring, sometimes I can see papers that they are using it, but this one is not that frequent. Also, what I was able to see, even in case of vector autoregressions, that people are taking the data minus the mean. Because you know that z-scoring is data minus mean divided by the standard deviation. In this case, they are just ordering it. But when I tested this method, because even from the people from the Hungarian National Bank at the conference, they were suggesting okay, we should always do this work, but because it will just create a fixed effect model, or it has a behavior like this. But Eviews should do this in the back, because you will have different, or you will have the same results if you are doing it or without doing it. So that's why it can be nice, but on the other hand, for me, it had no practical result, because my results at the end of the day were completely the same if I was taking them out or not. So z-scoring can be nice, but this one is highly relevant. So number of variables and the length of the data set. So in many cases, when we are building a beautiful model and after that it's utterly useless or not running or fails or just worse, then usually people are failing to meet this agenda. So obviously you need some kind of a length for a time series or even for a panel database. So usually they start to work nicely if you have 30 data points. So 30 years, 30 quarters, 30 months. If it's shorter, then still you can make them work, but the problem will be that it will be harder and harder to deal with or increase lag numbers, and that's why it will be harder and harder to deal with autocorrelation of the data. So this is the sad part.
So yes, even for panel data, it should be like tricky because we have cross sections, so they can compensate.
Yes.
So time series should be shorter.
Yes. In this case, panel has this benefit, but also if it's shorter, then usually you have to move towards GMM or dynamic panel, because otherwise, and still the problem will be that if you have, so the number of anomalies, artifacts in the data will start to merge if you are shrinking the length of the data set. But also oversaturation can be another problem. So if you are going above 100 significantly, then it will be also hard to achieve significant results. So in this case, p-values will be problems. So this is also my experience, and also sometimes literature says that, okay, you have this issue, and number of variables also it should be kept limited. There is also this problem that, okay, you would like to add a new variable to improve a already existing model, but you can't create overly complicated model because sooner or later it will create a conflict. So usually, if you are planning a model, then it's a nice, or if your model is not working, then it's always nice to check that, okay, it's not working because of these fundamental reasons, or because it's not working because it's not working. So different reasons. And yeah, the other thing, lag number. So that's also the simple rule for lag numbers. So usually we are trying to cover 1 year in terms of lags. So if you are working with annual data, then one lag is completely enough to look backwards. In this case, autocorrelation will be managed in most of the cases. Also, if you are working with quarterly data, then this is why we are setting lag to 4. Or in case of monthly data, we are starting with 12. But obviously after that, so this is the initial setup. So after that, you can test it back and forth. You can look for information criteria that, okay, what is AIC suggesting, or I prefer much more like in this case AIC because still we need complexity for our model. But you can follow them blindly. So it's still guiding you, but it's not an automatic or mechanical thing that AIC says something, and after that you have to set the leg number to this thing. Still, you have to look for the output diagnostics. So this is what is crucial. So first of all, I will take this down because hurting your eyes if I'm just moving it around. So, if you are looking for historical data analysis, so we would like to see what happened in the past, then we should focus always the lack of autocorrelation in the residuals. If you are focusing or would like to use forecasting models, then normal distribution of the residuals is a must. It would be nice to say that both of them must be achieved, but usually this is not the case. So at least the preference must be that in historical data analysis, we should have no autocorrelation. So it means that Darwin-Watson should be around 2, which is usually, it depends on people, but in most of the cases it should be somewhere between 1.8 and 2.2, or sometimes 1.85, 2.15. Doesn't matter, so within this range. I had this argument because in the past, one of our friends, PhD student, had a thesis, and one reviewer was saying that, oh, Durbin-Watson is not around 2, and yes, but what is the appropriate range for this? Because her Durbin-Watson was, let's say, 1.87, so it was close to it. so after that, yeah, it was still appropriate, just the guy tried to become wise. Or otherwise, in other models, sometimes you don't have Durbin-Watson. It depends on the software and the model itself. So sometimes we just have Young box or some Q statistics or anything what the software is trying to provide us. And obviously, if you don't have if you have autocorrelation within the model, then the problem will be that we have really nice coefficients, just the whole thing is biased. So we cannot trust the results. So that's why leg number must be increased. Leg number of the variables, leg number of the epsilon variable itself, but something. And also at the same time, we can look for seasonally adjusted data. So if we can see that, for example, impulse response functions are looking like a seesaw, then and also autocorrelation fails, then we should check the seasonal for seasonal adjustment. My favorite method to achieve seasonal adjustment is to download seasonal adjusted data from the database, Eurostat or somewhere else. But otherwise, Eviews can do it, or we can fit an HP filter on it, or something like this. Okay, but central bankers absolutely don't care about autocorrelation, as central bankers were telling me so many times. So since they are focusing on forecasting models, then for them normal distribution is necessary. So that's why they are using more dummy variables to remove outliers. Even we should see that which variables are contributing to the lack of normal distribution. So in this case, we should create dummy variables which are variable specific. So in this case, we try to overcome. Increasing or decreasing leg numbers can also help to achieve normal distribution. So in this case, for them, this is crucial. For me, when I'm doing historical analysis, usually normal distribution is not a factor here. Yeah. So, okay. Next thing, yes, we can use all the p-values under 0.1 in social sciences. So I think this thing is not 1. And Oh, yes. If we can see that our p-values are looking strange, then also it's a good sign that some exogenous shock like recession, oil price, change in the monetary regime, something like this was not represented. So usually what we are doing that we have always a set of dummy variables and we are adding, removing them back and forth to see that how can we fine-tune the model. So that's why usually you don't have just luck that you are running first time a regression and then you have a result and then you can go home. It would be so nice. But usually what is happening here that you are running the model under different setups, and once you can see that, okay, now it's goodish, then you start to add and remove also dummy variables to refine them more, because yeah, sometimes outliers can just bias the data. Next thing is R-square, which is still people are using it in time series data or in panel data, but it's utterly useless because if we are using lag data, then the R-square will be increasing. Also, when we are focusing on complex macro-financial data, or anything which is related to macroeconomics, so it's not cross-sectional query type data, then the R-square will be always small. And lag number will increase the R-square because you are just adding more and more variables. So, so sometimes people are publishing it or adding to the table, but it's not used for anything later on in the text. So even if it's added in the table, after that it's not analyzed anyhow, because in time series analysis R-square is meaningless. I was even asking people from the US Fed when they were publishing also such models at conferences, and they were always telling that no, it's R-square is utterly useless for us. Sometimes still people are publishing it. Personally, I don't know why. So, okay. Yes, dummy variable regime change. Okay, this is from other central banker feedback. So many years ago, I was focusing on the introduction and then the disappearance of capped exchange rates. So when the Swiss National Bank was capping the appreciation of the Swiss franc against the euro, and then when they removed it, and I had to represent it with a dummy variable within my model. And this was not significant. So what I had done, I removed it. Don't need this. The problem was that in this case, central banker guy from the Swiss National Bank told me that you should put it back because still, this is an exogenous shock still. Even if it's statistically not significant, otherwise it defines that what is happening behind your model. So, yeah. So if you have relevant things which are describing institutional or structural change behind the model, you should keep it there. Okay, but now let's talk about VAR models where two-step regressions are quite boring, so I would like to focus on the fancy stuff. So VAR model is really good in any macro data related analysis, because in many cases you don't know the causal relationship, or there can be multiple feedbacks. So the inflation is affected by the interest rate, because obviously interest rates will define funding costs for the aggregated demand, and aggregated supply balance will determine the inflation at the end of the day. And also central bankers are inflation targeting, so they are setting their interest rate according to the level of expected inflation. So there is a circular relationship where past or future values of the variables will have an impact on each other. The same thing is valid for exchange rates, where we can see that inflation has an impact on the exchange rate. So if you have high inflation, then the exchange rate will depreciate. But also if the depreciation is there, then the inflation will increase. So if we have this multiple feedback mechanism, which can be called as endogeneity, then we have to manage this. And the way how these people managed it in the past was the creation of VAR models. In this case, we are assessing that all the past values, at least the set like number defined past values of the model, will have an impact. And in this case, we can ignore endogeneity. So it's nice. The problem is that after that, how can we use this model? Because there will be many different specifications. And before jumping into equation land, what matters the most here is how the theoretical causal chain will affect us. So the loading order matters. So in all the other regressions, we are always saying that, okay, I would like to analyze this variable with this and this and this and that variable. Now, in case of VAR models, we are loading in the data from the biggest impacting data, so which is the most important, which will have an impact on the rest of the variables, and then going down until we are reaching the end of the causal chain. So, for example, in my examples, that I should load in the US Fed interest rate data, then I should load in the ECB interest rate data, then I should just check the domestic inflation, then I should also check what is happening with the domestic interest rate, and at the end of the day, I should see that what is happening with the exchange rate. So if we are going through this chain of thought, so, and if I'm interested in, let's say, the exchange rate, then after that, I will always look for the impulse responses. And then I will select that one. Or if I'm interested in the inflation, then I will pick the inflation from this one. So that's why it's different. And in this case, regression equation is never published. So they are not focusing on the equation itself. They just care about diagnostics and care about impulse responses, variance decompositions, and that's all. So, and also we can, why it's good? At the same time that we can use it for forecasting, and it's highly efficient. So this is how central bankers are doing their models since 1982, when Siemens was creating this approach. So if you are checking any kind of model which is coming from a central bank, this will be some version of the VAR model. Okay, so I think that instead of focusing on these things, let's check the practice, because after that it will be more interesting to see that how these things are working. Okay, so I've already this VAR forecast XLSX, which I'm hoping that Eviews, user objects. Okay, let's overwrite it. Yep. So first of all, if we would like to see or check these models, so we should see how the theoretical model looks like. So in this case, this one is a highly simplified international Fisher rule, where we can see that there is this euro-US dollar exchange rate, and we have the sovereign premium, so the difference between US and French long-term government bond yields, and also the differences in the inflation CPI level or harmonized consumer price indexes. And also we have a nice recession dummy, because dummies are always cool to have. And after that we have some time period. Yeah, so the first mistake in terms of forecasting, which is absolutely not published by the documentation. It's published in the documentation, but usually not highlighted enough, that also you should prepare the period what you are trying to forecast. So you should always define that, okay, these are the time periods where I would like to forecast, and also in this case you should determine the level of the or values for the dummies. So if you are forecasting anything, then you should prepare it. Otherwise, economic software will glitch and doesn't tell you anything. It doesn't matter we are using Eviews or we are using Gretel, the problem will be always the same. Okay, then next thing, I will create the input here. So the next thing is that we should create the specification. So I already highlighted the relevant variables with yellow. So we can assume that endogenous variables will be these ones. But again, so still we have to think about the hierarchy between them. So the loading order or identification, sorry. So identification, well, let's start with only the identification matrix. Will look like this, that okay, we have the inflation premium, so shocks will come from this direction, and then there are the effects. So then I mess this up because I should do it sideways. Now it's good. So inflation premium, then sovereign spread, and then at the end of the day the exchange rate. So we are assuming that there will be one shock. Sorry. So there will be one shock, there will be another shock, there will be also a shock here and here and here. But otherwise they have zero impact. So inflation will have an impact on all the rest of the variables. Sovereign spread still has an impact on itself and US dollar, and at the end of the day US dollar will have only an impact on itself. Sign restriction can be also added where we are saying negative, positive, but this is additional or later subversion of this one. So at the end of the day, if we created our identification matrix, and this must be always attached to the paper. So this is when most of the arguments can happen if the reviewer is not satisfied with the structure. So that's why this will determine the loading order when we are again just taking the same structure but we used here, and after that just loading them in a specific way, and obviously we should use differentiation. So luckily in Eviews we just have to use the D and okay, so we have to determine the log number and also exogenous variable, and in this case recession. And log number, what is this? Is quarterly data, then Eviews students.
Eviews students?
Yes. And and after that, hitting download button, and then
Download Eviews.
yes,
Student version.
and after that, students were able to use it. So there is one difference that okay, this is just for the 12.
I have 13. I'm looking for 14.
Yeah. But otherwise it works nicely. Okay, so sheet 1. Yes. No, never link external. Yep, I should update this one. Okay, so if we are doing forecasting, then if we are just analyzing historical data, then we don't have to deal with the sampling. But otherwise, there is always this rule that training data must be cover 80% of the existing data set, and then the remaining 20% will be the test. However, the problem is that since we are living in this 2020s decade, which is absolutely rich in pandemics, wars, shocks, inflationary periods, and so on, which would render our training data absolutely useless. Nowadays, what I can see that many people started to increase the training period to 90%, and the remaining 10% will be used for test. Yeah, 50. Let's just still okay, so I should use this one. Okay, so I created a subsample here. Then after that, in quick menu estimate VAR, we just start to drop in everything. So this is why we prepare the data this way, because now we can see that we have to set the log interval here. Also, we can see that the estimation sample will follow the sample here. So we could also set it here, but in this case, if we are running different setups, then it would we should never forget. Also, the difference between the recent version and the older version of the VAR models, that now they added the Bayesian TVC VAR, never worked with that one, and I think mixed frequency is also a relatively new thing, but I never worked with these two things, just I can see that it was not there before. Switching VAR is really nice, just it requires so many time, even at this computer, that It would be fancy to have them, but I don't have the time infinity to wait for results. So yeah. Okay, then we can hit enter and then we can check for. So again, in the cookbook, then we have to see that diagnostics. So we should look for the lack of autocorrelation. So view, residual test, autocorrelation LM test, obviously. We can use portmanteau, but usually the people prefer much more the autocorrelation LM test. So log numbers are already specified, so we don't have to do anything here. And at the end of the day, we can see that this looks nicely because it's higher than 0.05, so it's for historical analysis we can use this already because it's not biased. So this one is cool. Then normal distribution is the next question. Can we use this for forecasting? In this case we have a set, and in this case nobody was telling me anything, so usually it's not defined that which normality test was used by the different people. When I was learning this from people from the French National Bank, they were just saying that you should pick one. Okay, guys? So
there's so many people like checking their pair.
Yeah. So Jargbara is the usual way of normal distribution checks. So, this one is the not disclosed part of the analysis. So this one is proper. Just still, I would be happy to have some kind of a citation that this paper or this chapter in this book was telling that, okay, we should follow this one or that one, but this one is like just spicing up food. That's okay. So we can see that at the end of the day, this one fits well, so the joint test, but also at the same time, we can see that variable 2 has issues. So which one is variable 2? Sovereign spread. So maybe if it would not fit in there, then we should check for outliers within this data and then represent it with the dummy. Maybe it would solve this. But right now we can say that luckily we can also use it for testing. Or we can say that yes, but we should optimize also the leg length. So maybe it's excessive, maybe it's not excessive. So let's set to 8. And so right now we don't have any anomalies in terms of diagnostics, so we are not forced to change the lag number, but if we would be, then I can see a thing because these are not numbers. Now I can see. So here EIC says that we should have only 3/4. BIC said that we should not have anything. So in this case, we can still say that my original set of 4 is quite a good conservative choice because it's not interfering with the residuals. We already have good diagnostics. We are always fighting in this. So there are different schools. Some people are saying that let's forget all the diagnostics here. But come on, guys. We should have good diagnostics because otherwise all the results will be rubbish. And still we could say that impulse responses will be robust enough to manage most of the anomalies, even if this one is not working here. But I can teach things to use in the wrong way. So we can say that, okay, lag number is good enough. So we are using this one. It says that, oh, 3 would be completely enough. Obviously, we should test for both of them. So let's see that what happens here and there, but otherwise we can say that we can start with this.
So,
Yes?
especially recent papers, I saw that many of them totally don't report normality tests, and they publish in Q1. Also, I found many that they report and it shows that the regression is not normal, but still they publish in Q1 and Q2.
So until you are not forecasting with this, then you don't have to care about normality. So if you are building a forecast model, the normality is a must. But
forecast, you mean?
If you would like to see what happens in the future, so here in 2023, where I don't have data and I would like to forecast, then this is the normal distribution is crucial. If you just would like to analyze what happened in the past, then normality doesn't matter at all.
Doesn't matter.
Yes, it's. In this case, we can completely ignore, so that's why they are not disclosing it. And also, panel VARs are not good for forecasting. So this is only for time series VARs. I will talk about panel VARs later on. But again, in this case, autocorrelation should be at least tested. Okay, so if you are not using the regression results or coefficients, then obviously impulse responses are for friends here. Then you can see what I'm doing. Okay. So in the usual setup, we just go for the ordinary impulse responses, and what we have here, let's focus on the exchange rate. And let's look 3 years ahead. Display using lines, 0.84. Okay, I set it to everything. So in this case, just the response, what is relevant for us. So only the exchange rate. In this case, you can pick anything if it's for your interest, just I'm an exchange rate guy. Also, confidence interval, I have to talk about it. So in this case, what we can see here, that the time, the horizontal line represents time. So the impact of the 12th quarter before data is on, or the shocks coming from the inflation period 12 quarters ago on the exchange rate. We can see that this one is 0 or not significant, sorry, because how to determine the significance here, that the medium line, the expected value should have the same sign like the confidence intervals. So right now, none of the inflation data is significant because they are always mixed signals. So this one is positive, this one is positives, but these are negatives. And actually none of my results are significant here as well for the sovereign premium. But at least here I can show you significant results because on itself, in the first quarter, there is an instantaneous positive feedback that if it's appreciated, it will appreciate further or depreciate further. So there is positive feedback. Next thing, confidence intervals. A year ago, I was in a fight with 1Q2 journal because, again, central bankers have a tendency to publish nowadays only the 84% confidence intervals. So they don't care even about the 95% confidence intervals, because obviously this way is way easier to achieve significance because the band is narrower. Why 68%? Because this is one standard error away. not two standard errors. Two standard errors are the 95% confidence interval. One standard error is just the 68%. Some paper says that this one is even more robust against different exogenous shocks, so it performs better, more reliable. We can find a huge literature where they were just using this one. Still, my pet reviewer was saying that I cannot say that this is significant result, and oh my god, still I had to collect a whole paragraph of literature reviews that were saying and using this way. So yeah. So in many cases, at least at the level of interpretation, we must be careful to say, or at least cite relevant sources where they are opening the door of 68%, even if people are using this in important places. Okay, so in this case, we can't see a thing. So we can go home, sadly, or we can go for different model setups. And this is where the fun begins, because we have many different setups. So in the procedures, estimate, structural factorization methods, we have a set of varieties. Okay, when I was learning it, we had only two options. So this is the short run impulse structure, what you were able to see. This one is hardly working. So sometimes if we are lucky, then we have results here already. Usually this is not the case. In many cases, long-run impulse responses are much better in terms of performance, in terms of achieving good results. So this is my experience. That's in many cases we have to go for the long run. This is the Blanchard-Coa representation. In this case, we don't have any diagnostics here. Just we can go for the long run. If it's allowing us to run, then also we have to show you that now we are going for the structural decomposition here in impulse responses. And also what is relevant, that we should have accumulate responses. And then, yes, we have different approaches, but right now let's use only the analytical. Did I improve anything? Okay, only here. So right now still we can see that shock 1 was inflation. The next thing, sovereign premium, and the last one was the foreign exchange. So, obviously, in practical analysis, we are comparing many different setups, but this is my second model setup, so we can see that at least I was able to achieve some really poor, but at least significant, that's 68% confidence interval at an instantaneous impact at the inflation or at the sovereign premium here. So that's why nowadays some people, even from the Polish National Bank, were saying that if you have such a useless result where you don't have build-up for time, because it would be really nice to see that, okay, it's nice, and then it disappears. In this case, you can even use an OLS regression for the data, which seems to be a crazy idea, but for them it was working. Just I'm not sure that what would the reviewers telling in this case. But now we can see that, okay, the sovereign premium has a negative impact, so or currency will appreciate because I used the wrong structure here. So it will appreciate if we have positive interest premium. So okay, let's copy it to the so results. So impulse response functions are showing us, practically we have multiple coefficients for each quarter of years to see that what is the impact of the individual variable on the variable of interest. So this is much better than just checking one coefficient because we have 12 of them and we can see the impact of time. If you can see also scissoring, jumping back and forth data, it means that you have seasonality, or it can happen also that your time series are short and then they start to make up data on the short run. So usually what should happen, that it should go near zero and lose all its significance by time. Or should we utterly use this like here? But the impact or relevance of each variables, so is this a good model or not? Because right now we can see that it's quite a meh one. Then we should go for the variance decomposition. In this case, we don't need confidence intervals, just good thing. Okay, so in this case we can see the relevance. So this is a 100 scale, so 100% for each leg data here. So what we can see here, that inflation premium, yeah, it's poor because it has only less than 5% of weight in determining the US dollar exchange rate in the first quarter. Sovereign premium matters more because it has nearly 10%, and as time passes, usually these things have a tendency to increase. Or sometimes they are not doing anything. So what we can do here, that if we have multiple variables and we can see that one variable has 0 or close to 1 or 2 weight in the variance decomposition, then we can drop them. We don't need them in the model. Usually it increases the performance. And or for example, if we can see that still it's quite useless because we are just describing 80% of the whole changes, then we should add further variables. So this is the omitted variable problem, that we did not add relevant things yet because obviously central banks were focusing on the implementation of their unconventional monetary policies. So the sovereign spread, which was a nice variable 20 years ago, now it's utterly lost its value. Also, inflation premium is completely useless at the same time when you have long deflationary periods with terrible or lack of growth and recession. So that's why this classical model fails miserably. So we were able to prove this. But can we use it for forecasting? Because still this is a question, that we were building something which is not highly the best model to define what is happening here, but at least can we use it for forecasting. So in this case, we can, usually people are using dynamic forecast, coefficient uncertainty with standard error calculation, so we need error bars, SE suffix, SOF, and forecast sample. So this is, I don't know why, but we have to define it manually always. This is made automatically by Gretel, but but not by Eviews. Okay, let's save this one. Race time period, okay, and then we have the following things. So, so if we are doing any kind of a forecast, it doesn't matter it's VAR or other method. Today I used the review the paper, which was completely different, but still the problem is the same. So may or MAPE values are always defining that the accuracy. So how good you are in finding the average value. It's like shooting arrows. If you can shoot bullseye, then you are perfect. If you are shooting around, but still in average you are shooting all your arrows in one specific point, then you are less accurate to find the mean. So that's why in this case we have to look for models which have the lowest values in terms of May or MAPE. But if we are just have one model, then this is useless because we can't compare with other models. So we need a second model at least to show something that this one was better. So in this case, people are just creating a second model with different assumptions, or removing a variable, or just before adding your variable, then you are just running the standard model and then adding your variable and showing us that, okay, the main number is now smaller. So in this case, we have to always look for the lower value. No, because this is not a function. Lower value. RMSE is the same thing. In this case, we are talking about accuracy. So what is the standard deviation? So if we are shooting arrows, then we have a scattered plot of shooting arrows everywhere, or they are concentrated around the mean. So it doesn't matter. Both of them should be minimized to look for or find a good model. And after that, we should check that what was predicted for exchange rate. So in this case, model suggested us that nothing will happen during 2023. So euro-US dollar exchange rate, according to these key macro variables, will be the same. And also we can see that the confidence interval is increasing, but until it reaches 0, then this result is significant. Just you know at the same time that the model behind this one is also really weak. Yeah. Okay, so now you know everything about vector regression. So this one is not a great deal. The next question is that how can we use this? So what is the difference when we are thinking about a panel VAR? That's one thing. Next thing is that how can we fine tune it? Obviously, you have to start to add or remove variables. You have to play also by changing the identification matrix. So in many cases, people are suggesting that you should change at least the ordering here, so ordering here as well, to see how robust are your results. But at the end of the day, the identification matrix must be convincing. And this one must be always added to the paper. Once we forget it, or I added it and then my co-authors deleted it because of character numbers, and we got really angry result or really angry feedbacks from the reviewer. So you must keep it there always. And so fine-tuning can happen with playing with the dummy variables. Also, with exchange rate, we can play that, okay, if we are using different denominations, if we are going from, let's say, US dollar denomination towards nominal effective exchange rates, real effective exchange rates, it can also change the picture because this country-specific thing can be removed from here to there. So in case of VAR modeling, it's never one estimation, it's always multiple ones. So you can play for a week, and after that you can see that what sticks on the wall and what is not remains there. And in this case, you can at least decide that what are the robust results and what are the anomalies, because sometimes we can be really happy with something, and after that you can realize that, okay, that was an artifact. And it's much better during the writing period instead of submitting the paper. Okay, so now let's go towards the next thing. So instead of focusing on panel yet, we should determine the next thing. My bad. Yeah, that's why I was using inflation. So before focusing on alternative or anything like this. So in many cases, what we can see here, the inflation was completely useless. In this case, we can start to think about the variables that maybe we should separate them, to split them to positive and negative variables, which means that if you are above the inflation target, under the inflation target, if the inflation difference is positive, if the inflation difference is negative. So such non-linearities can be relevant for the model. So right now, I did not prepare the data this way. So let's say that inf frame positive. So if this variable is bigger than 0, then if it's true, then this will be this one, otherwise it's 0. So in many cases we can save the model. If you are just cutting them in half. Okay, so now, and the next thing that if you are using Eviews for anything and you are changing, you should close down the whole program because just to not to save anything. Because Eviews, the stability of the program is like somewhere between an egg and a feeder, so it's absolutely not stable. It will collapse if we are giving any possibility to it. Okay, so now my structure should be a bit different. Okay, so let's copy it here. And now I moved to extend this with the additional inflation variable. So We can keep the rest, but we will add differences.
So sorry.
Yes.
Are you running with a level and a close difference?
No. Oh, everybody's difference.
Difference.
Yeah. Now it's still standard VAR without any fancy things. Just four. Our estimation range. I did not change that one, but in this case we can change it here. Just we should not forget that. We have to rerun this. Then. We have different results, so let's go for structural. Sorry, no. Diagnostics. Blah, blah, blah. We can see that it did not create anything, so autocorrelation is good. Then also we should check that normality is also good, so we did not made any harm.
Which test is the second one?
Normality. Well, I'm using only normality test because I'm forecasting at the same time, so it's a show off, but okay, let's see that. Oh, first let's check let's run the no run, but because response is first we will see just the simple short term not accumulate, but US dollar euro. So, was I able to achieve anything in terms of short run modeling? Not much. Okay, but this one is the not much category. But I was able to create that at least sovereign premium has now a positive tendency here, but this one is quite poor. So let's go for the structural decomposition. Now it's accumulating. Good. Okay, so this was the plus. Minus. This one is the this one is the FX on itself. So at least I was able to see that, okay, if inflation was, okay, in this case I don't know which one is bigger or smaller, but so in one country we had higher inflation, then the currency reacted with depreciation, which is nice. So at least this is following book. And also we can see that this was at 95% confidence interval, and still after that at 68 confidence interval, the thing was existing for nearly a year until, and even after a year. So this one is quite correct. Also there was a immediate appreciation in the first quarter, and then something in the second. Nothing, sorry. What is this? Oh, it's still positive. Okay, so we can see that this one is positive. Now it's not, now it's zero. Oh, this one is positive. So we had also something in the positive direction. So that's why it can matter when we are cutting the time series to pieces. Okay, in terms of sovereign premium, this one is utterly useless. Again, because of unconventional monetary policy. So this is not a surprising result, unfortunately.
So you give shock to inflation premium. Which variable did you give the shock?
So I'm just in this case, I was separating the values, positive, negative values of the inflation. So I separated them to two variables. And in this case, I'm just comparing US and French inflations.
I think impulse responses. Which one?
Yeah.
Which one will give the shock?
Yeah, the shock.
Yeah. Which one will give the shock here? Shock here. Yeah.
Okay. So I'm just looking from the foreign exchange rates perspective here, and the rest is. And then variance decomposition. Now we can see that also it started to improve. Because now we can describe way more of the changes of the data than just have to copy them here. So sovereign premium is useless, but once we started to separate the inflation according to its sign, then we can see that it's behaving much better. Usually people are saying that this is because of the long deflationary periods of the 2010s and then the inflation shocks during the 2021, 22s, and that's like 23s as well. That's why it's much better to check it this way. So if you have any database which has this sinus curve-like behavior, then it's much better if you're just separating them. Also, what I'm not doing, but people who are much more experienced are doing, then they are multiplying the variables. So yes. I'm really terrible in this one, but if you are saying that, okay, inflation and the sovereign premium can be multiplied, and after that we can add this one as a separate variable. So instead of removing both of them, we are adding this one as a third one. In this case also we can see that they are reinforcing each other or weakening each other. But I never tried this. I mean, I don't have experience in terms of publishing a paper which when we were using this one in huge masses. Trumboy had one paper where he was using this one, but unfortunately I can't talk about it because I don't have my practical experience with this. So I know that we can multiply it, it will have nice fancy impacts, just I can't tell any further things about this one because of my lacking experience. Okay, but still, if you are cutting them, then can be used them for forecasting. So again, forecasting periods. This one. So now we can compare things. Obviously, we should just look for this one and compare it with the other one. Does it have any added value in terms of forecasting if we are just creating this or making this separate values? So this is the original. And what we can see that no, it doesn't have. So this one is lower, this one is lower, this one is also lower. So at the end of the day, we can say that, yeah. Even if we can describe nicely the data set with it, and it happens in many forecasting cases that the forecasting models is disgusting when we would like to describe the time series, but otherwise it fits nicely and it can forecast. So what was the end result? Yeah. So it said also that there will be a decrease in term premium. Sorry, sovereign premium, which is valid. But the problem is that this is not what happened. So there was a significant depreciation in the euro. So still we have this issue of complete blindness in terms of model behavior. So yeah, so we can play with the separation or multiplication of the variables, and after that we can improve them. Okay, next thing can be that we can start to play with the different what is this? Confidence intervals, yes. Confidence intervals. So obviously we should not just testing for analytic, but sometimes or Monte Carlo estimations, which is nice. Just I did not want to use this one. Why did you forget about my settings? Why did you accumulated? Okay, the rest is good. Yeah. Well, Monte Carlo prefers to have this trumpet shape, so we can say that does it have an added value compared to the asymptotic one? No, it doesn't. So again, it's cherry picking that we should find a good way to describe the confidence intervals. Now they added all these other confidence intervals. And the problem is that, I will show you the problem. So this is the fancy thing from the Eviews 13 and 14. And the problem now that, so in the old-fashioned models, the medium line is always in the middle. But in this case, this is asymmetric, so it can be anywhere within the confidence interval. So sometimes it's going through the confidence interval. So this looks nice sometimes, but this is hard to sell to the reviewers. So if you are lucky, then this will be okay. So this one is absolutely not significant. Come on, the blue line is way above the graph. So this one is dead. You cannot use this. So this is the big problem here. It looks fancy, just I did not find so many papers which was using these approaches. Okay, so let's go back to analytic. Next thing, estimation method, ordinary. And this is a technique what I'm still learning. Okay, we cannot use it for structural because it will die.
Eviews 14 has this kind of function estimation?
Yes, this is the new. So local projection is the new thing. Not that new, but now it's central bankers are preferring it more and more. And my colleagues at the academy were also preferring it more and more because it's robust and so on. The problem is that it's not that great in Eviews, to be honest. So I still hesitating how to teach it. Still, it's a work in progress. So I need at least 1 or 2 years until I have enough experience in terms of publishing also papers with LP. But this creates also an additional impulse responses. So it is another fancy way to create impulse response functions, which is preferred nowadays by central banks. Still, we can see that journals are still not rejecting papers if they are not using it. So we cannot say that the old versions are outdated, but this is the future right now. So, but this is a terribly implemented future into Eviews. So they added this only in July when the new version was published. That's why I had to purchase Eviews 14. How we can show it, because not just for time series but also for panel data. They were adding this one. But there are so many bugs, so many failures. Also, it has a miraculous variance decomposition, but you should not have. And also, this is not working at all. So, if people are using local projection method, then they are not publishing the variance decomposition, or they are publishing the traditional VAR-based decomposition, because this one is nowhere near 100, nowhere near anything, so this one is useless. So you can push the buttons, and after that the end result is disgusting. So also the documentation is non-existing, not working within the Eviews, so I can say that I'm a satisfied client at this point. In Stata, they already had a Stata package which was developed by the Jorda, who was developing the whole LP structure. So right now, if you are interested in local projection, I will recommend you to use Stata, because if you are just typing in Jorda and Jorda, who is a Spanish guy, I think, and local projection, then the first, first Google find will be his website with all the documentation, all the Stata packages and all the things there. So, well, otherwise you can have pretty good results, but Eviews is right now, it's maybe some upgrades will solve this one, but right now it's a huge mess. Okay, so with this disappointment, it's time to end today, and next week we will continue our journey from here with VCM models and other implications of all these things. Okay, so
was a one question perfectly possible. So
yeah.
You are using mainly